Page 211 starts lesson 4.1, which is on constructing and interpreting scatter plots. Scatter plots basically is, in real life, when we graph something that has two variables, x and y, for example, the points don't always line up exactly as a straight line, so they are scattered around, kind of. That's where they get that idea of scatter plots. So we're going to be looking at those lines and looking at how we can make interpretations and predictions and things based off of the points that we've been given. So on 211, Luciana is starting a 2-week social media campaign to attract new subscribers to Blast On, a music website for teens. She has the following data from her last campaign to help plan her strategy. Okay, so you can see looking at how many posts per day and how many new subscribers she got. So they're asking us, based on this data, what should Luciana's strategy be for the new campaign? So different possibilities here. So one idea here, if you look at the chart, is that she got the most new subscribers when she did 5 or 6 posts a day. So she could just go ahead with that. Another option would be posting more than that. The most posts she's ever done is 10, so she could try 11 times. You know, she could try other things. 10, if you'll notice, she only did 10 one time. She didn't try 9, you know, but again, it looks like that 5 or 6 posts a day seemed to be working pretty well for her. And, you know, at some point, you know, you're just not necessarily just going to keep getting that same amount of subscribers every time. So example 1, Luciana analyzes the data collected to determine how long after posting a new blog her new homepage received its maximum number of new views. Her data are presented in the table. How can she determine whether there is a relationship between the time after the posting and the number of new views? Okay, so we're going to try to look for a pattern here. So you can see the first blog post, after 2 hours there were 350 new views. The second blog post, 6 hours after, there were 50 new views. The third blog post, an hour after, there were 500 new views, and so on. What we can do with this is we can make a scatter plot so we can visualize this a little bit better. It's hard to get an idea just looking at this table exactly of what's happening maybe. So we can actually draw the scatter plot we've talked about. So a scatter plot, it's a graph that shows the relationship between two sets of data. And like I said, the points, when you graph these, the points are just going to be scattered around. They're not going to be necessarily in a straight line. In real life, you know, things are not always perfect, or very rarely, so it's not likely that we're just going to get a straight line graph out of these points that we're doing. Okay, so once we have this set up, if you'll notice, they made labels. X-axis is the time in hours, Y-axis is the number of new views, and then they graphed these points: time after posting and number of new views. Okay, so if you look at this, we can kind of see a pattern here. Okay, it's not a straight line, but we can kind of see a pattern of what's happening. We could even try to draw a line that kind of approximates that, just to get an idea of what's happening here, even though that's not exactly what's happening. And then we'll be talking about this more in the next example, but basically what's going to happen here is, if you'll notice, the longer the time, the less new views there were, right? The further we went over this way, the less views we had. So if you notice on this line, if we draw a line to approximate that, what kind of slope does that line have? Negative, right? Okay, so that has a negative slope, which means this has a negative relationship, or as the book's going to call it here, a negative association. Relationship, association, okay, those words get used interchangeably. Some books say relationship, some say association, so if I say it the opposite of how the book has it, just understand both of those get used and mean the same thing. Okay, so what that means for us is that negative relationship means the longer it's been since the post, the less views that it's going to get, and that kind of makes sense. On the Try It, Luciana collects data about the number of entries and the ages of the subscribers who enter the concert giveaway. So there's some information in the table. The point that represents the data in the fourth column has what coordinates? So columns go up and down, so we'll just say this is the first column, second column, third column, fourth column. So fourth column, and they don't necessarily tell us, but usually the X will be on the top or on the left on a table. So we'll just call that the point 13.9. And that's really all that they're asking us to do there. Not the most helpful example, but we know what columns are now at least. Example 2, they are going to give us some definitions and things. Again, I've seen the word relationship used more than association probably, so that's what I'm going to go with here, but if you want to use association, that's fine. So three different types of things that we could be looking at here. So one is called a positive relationship or a positive association. And basically what's happening in that case, again, these points are not going to be just in a straight line. But generally, if they're going up like this, in other words, if I would try to draw a line kind of through these points, it would have a positive slope, positive relationship, okay? Another way of looking at that is as X goes up, Y goes up. So the further we get over to the right, here on our graph, further we get to the right, the higher our Y values are getting. Okay, so X increases, Y increases. They're both doing the same thing. That's a positive relationship. Okay, because sometimes when we do these relationships, it's not always going to be on a graph. They might just be asking us about two different things without a graph. We could try to graph it out, but if you can just think about that in your mind, this one goes up, the other one goes up, okay, positive relationship, both thumbs up, we could say. Negative relationship, we just mentioned on the first example. So negative relationship. Okay, something like this. The dots are going that direction. So we could say as X increases, Y decreases, or X goes up, Y goes down. Okay, so this one you can see as our X values are getting bigger, our Y values are getting smaller. So that if you do the thumb test on that one, the one goes up, the other one goes down. They're doing opposite things as a negative relationship or negative association. And then our third option we can call either no relationship, or sometimes it's just called neither. So in this case, looks like maybe it's snowing or something. We've just got points scattered all over the place. In other words, there's no pattern. Okay, we can't definitely say if X goes up, Y goes up, or goes down. We don't really know what's happening. There's no pattern to it, and so there's no relationship to that at all. So if you look at example 2 in your book, the first part just talks about the definitions there a little bit. Let's talk about what the actual problem tells us. Rochelle asked 10 friends how many hours of sleep they got the night before a math test and matched the data with their scores. She plotted her data in the graph below. Did students who slept more get higher test scores? And you can see it looks like mostly they did, right? Another thing maybe to check besides how much sleep they got is how much they actually studied. So there is one point, if you'll notice, that doesn't really line up mostly with the other points, that outlier. Okay, so this person maybe just decided to sleep, but they didn't even study at all. So even though they slept about the most out of anybody, they got a 40% on their test. Not real great. So besides sleeping, we also have to study too. So an outlier, it's a point that's set off from the other data points, the book says. I had a book before, and they had their definition, I think, would maybe be best said with a British accent. They said it is a point that is quite separated from the other points. Quite separated. Don't hear that one every day. A couple other definitions here. One definition also we can talk about is a cluster. So a cluster is points that lie close together. So if they're real close together, that's a cluster. So maybe we could say that's a cluster. Maybe this could be a cluster here. Okay. And then a gap is an area that contains no data. So like here, kind of in between here, we don't really have anything. So we kind of got a gap there. It's like a face. So example 3, Avery is the middle school basketball statistician. Okay, short for statistician is stats. So somebody that keeps stats is a statistician. So she tracks the number of minutes a player plays and the number of fouls they make. Her data are shown in the scatter plot. Is there an association between the number of minutes played and the number of fouls made? Well, if we try to draw a line here, don't see that we can draw a very good line that's going to represent this information. Kind of looks like it's snowing a little bit. And so this one is going to have no association or no relationship between the number of minutes and the fouls. So, you know, you got somebody that goes in there and they just get fouls right away. Okay, you can see somebody played for 4 minutes and they got 3 fouls. Maybe that's just a matter of who they're guarding. Just have a tough matchup of who they're guarding. But we can't say. In general, you would think the more minutes you play, the more likely you are to get more fouls. So we would think maybe that it would be a positive relationship, but with their graph here, we can see that that has no association or no relationship. On the try it, Avery also tracks the number of minutes a player plays and the number of points the player scored. Describe the association between the two data sets. Tell what the association suggests. Okay, so for this one, if you can look, it does look like there's a little bit of a pattern. Again, we can't just draw a straight line that's going to be connecting all these points. Okay, a straight line is not going to do that for us, but we could draw a line that kind of goes through the middle of these points. Okay. If you get some of these points on the line, some above, some below, that kind of gives us a hint about what this is going to be. So for this, you can see we got kind of a positive slope going. You could think about also the more they played, the more points they scored. Thumbs up, okay? We got a double thumbs up, means a positive association or a positive relationship. Okay, and again, it says tell what it suggests is just what we talked about, that the more they play, the more points they are likely to score. Not guaranteed, but likely. Key concept just recaps things again. Positive association or positive relationship. When the x values increase, y values increase. Again, we could kind of sketch out a line here that has a positive slope. We can talk about clusters again. I'm not sure how great of a cluster, but maybe something like that would be a cluster, we could say. I think of clusters maybe being a little bit tighter together than that, but anyway. Negative association, again, if we draw a line that kind of goes through those points, it has a negative slope. Remember, an outlier is quite separated from the other data, and then we have a gap is just a space in between where there's nothing. When you have an outlier, you'll have a gap. If you don't have an outlier, you may not have a gap. And then again, no association. There's not a definite pattern, just looks like it's snowing there. Do you know how? Number 4, Phoebe constructs a scatter plot to show the data. What scales could she use for the X and Y axes? So we're talking about height and shoe size here, so she has an interesting display for her chart. So the scales means basically what are we going to go by, what are we going to start at and go to, what kind of intervals are we going to use. So the shoe size, if we make that be the X and the height be the Y. For the X-axis, so the X-axis, lowest shoe size is 5, but usually we'll just start at 0. This would be for our scale. Okay, so our scale, we could start at 0. Highest shoe size is 8, so if we go a little bit above that, if you want to go to 10, if you want to go to 13, I don't know. I'm not sure where the shoe size is. I know with the kids' sizes, it like goes to 13 and then it goes back to 1 or something like that. It's kind of strange, but anyway, if you want to go to 10 or 11 or something here for the scale, would be fine. And then you could just go by ones, count by ones on the X-axis. Okay. On the Y-axis is talking about the heights. On the Y-axis, the numbers don't start until 54. That's a pretty big number to start out with. So one thing you could do on the y-axis is we could do a break. Okay, remember a break is a little squiggly thing, means we're skipping over some stuff. So technically you put 0, but then you squiggly line skips over, and then we could start maybe we could go maybe from 50 to 70 for the y-axis, and then maybe we could count by 2s. Wouldn't be too bad. Okay, obviously I don't want to count by 1s all the way up to 70. That'd be a lot of stuff to mark off. 50 to 70 by 2s, not too bad. If you want to go by 5s, would be okay also. Okay, and again, we could from there graph those points and then look at whether there's a relationship or not, but that's not what they're asking us to do here. Number 5, Jermaine constructs a scatter plot to show how many people visit different theme parks in a month. Why might clusters and outliers be present? So first of all, notice there's not necessarily just a positive or negative relationship. Okay, it looks like a roller coaster fittingly at the theme park. So why might there be clusters and outliers here? So the cluster up in the top here, we could say a cluster there might be because it's summer and we've got more visitors there. The outlier down here is maybe because it's colder. Interesting, we've got a little bit higher number here in January. I would think that would be the lowest. In fact, most theme parks would be closed at that time of the year, but I guess we're at Florida or something maybe. Maybe this is Disney and we've got people coming there for Christmas break or off time of work.